Hi there. Thank you for scanning my QR code. This is a bit of a cursory look at GPU architecture. If you'd like a more in-depth explanation about this architecture, please, I'd invite you to scan the other QR code after listening to this video if you are interested in more depth. This is just kind of a quick overview, first of von Neumann architecture, traditional CPU architecture, and then moving into why we even use GPUs and why they're really important. If we look at the von Neumann architecture, it's really quite simple from a high-level overview. We have input devices that then access or directly manipulate a central processing unit, and this processing unit has different control and logic circuits that basically allow for the computation of different operations that we want to represent in a computer architecture or in the actual circuits themselves. Then afterwards, the results of these computations, whether they be instructions or values themselves, are stored within registers, and then these registers that are basically hold these instructions or these results are then stored in memory for later use or future use in computations, and then this exchange between memory registers and control and logic units and arithmetic units as well that are used for computation is a constant cycle that goes, it's cyclical. It's a constant cycle. That makes sense. And then afterwards, the outputs of these computations or these instructions go from memory or even from these registers and into output devices that then we can see the outputs of computation, right? And this traditionally, what we think of right now is one core when you think about it in common parlance. So this is what a standard CPU would look like. It's this traditional von Neumann architecture. What we've seen in modern times is actually the expansion of this into either multiple cores or applications where the von Neumann architecture is expanded upon, right? For CPUs, it's actually very common right now to have multiple controls or more sophisticated control units with multiple arithmetic logic units, and that basically means we have kind of multiple cores or multiple ways in which to process information, and this is what we consider with multi-cored central processing units, CPUs, right? GPUs are a very specific use case for it in the sense that they allow for the parallelization of tasks. Now, what does that mean? That means you can do multiple computations at the same time. So very dense, very hard to tackle computations can be split amongst these core clusters that define GPU architecture. As you see right here, all of these arithmetic logic units accompanied by their own cluster of control units and caches, which caches themselves are little memory registers that store instructions and particular results from computations. Right? So these core clusters are good at actually doing multiple computations all at the same time. And what this allows is a huge throughput of computations and memory, and this is perfect in the specific use case for video games where you're constantly computing like changes in geometry and shading and different positions of shapes and whatnot. And so that's what a specific use case and why we want to offload certain computations onto the GPU, because the CPU then, if you look at the context of games, is also going to be loading other things like health bars or important information from the game that the developers want you to know. So you can offload these tasks to one dedicated processing unit and another processing unit, the graphics processing unit, to only dedicate itself to computing these very hard to tackle computations of shading and geometry, right? So this is a very quick and rundown, distilled overview of CPUs, GPUs, and specific GPU architecture basics, so you can understand that GPUs are essentially huge core clusters, right? Lots of different arithmetic logic units and control units smashed into one. So I hope that's helpful, and if you want more depth, please check out the more in-depth video that is also linked in the poster that you just scanned. So thank you.